Welcome to Electrical Brains. In this session, we are going to discuss about the topic on instruction set in 8051. What is the instruction set is that we are going to use a set of instructions which is to be given to a 8051 controller. Since 8051 is similar to that of a computer, it don't understand a user-defined language. So it will understand only in a set of instructions. So to perform various operations, we are using different set of instructions. So these instructions are of some types. Mainly they are classified into as 5 types, that is data transfer instructions, arithmetic, logical, branching, and bit or boolean manipulation instructions. Apart from this also we are having some instructions as conditional instructions, unconditional instructions, and rotating instructions, that is shifting operators. All those instructions we are having. In this session we are going to discuss about this. What are the various types of instructions we are using in 8051. First one is see the types of instructions. What are the instructions we are having? In a data transfer instructions, mainly we'll be using move instructions and push and pop instructions, and also some exchange instructions we are using in a data transfer. Data transfer is nothing but transferring of data from one destination to other. Next one is arithmetic instructions. Arithmetic instruction mainly perform arithmetic operations like addition, subtraction, multiplication, division, as well as it will round off the decimal digit, that is decimal address, and also some increment and decrement operations will also take place in arithmetic instructions. In a logical instructions, mainly will perform AND logic or logic, XOR logic, and this is a clear instruction and complement. And these RL, RLC, RRR, RRC are shifting operators. Okay, that is the rotating instructions, and as well as a swap instruction comes under logical instructions. Next one is a Boolean or bit manipulation instructions, that is which it performs Boolean functions, as well as some bit transferring will also take place in Boolean instructions. Next one is a program branching instruction, that is branching instruction is that if I'm going to write a program for ascending order or descending order in 8051, some programs will take lengthy if I'm repeatedly doing one operation. So by putting one loop, I can continuously run that loop till my program, till the value what I have assigned is executed. So that is called as a program branching instructions. And these are the main instruction comes under these types of instructions. The data transfer instructions. Already I said that which it will transfer data from one operand to the other, or from a register to the operand. Like that it will transfer the data. See, main functions we are using it as move, move C, move X, push, pop, exchange, and exchange digit. Here they have given some instructions. Okay, and what operation they are performing, that is the description here, and in which type of addressing mode we are using, and the number of bytes and number of cycles taken to complete this instruction. These and all given here. See, first instruction is move a comma hash data. This is a instruction format, but this move instruction should be like move operand 1 comma operand 2. What is the syntax is that it must be like this format only. That is called as a syntax. That is, if I'm going to take a write instruction and using move, then that move instruction should follow this format. That is move operand 1 comma operand 2. That is, it must have 2 operands. See, move a comma hash data. Here a is the operand 1, operand 2 is data. Similarly, all instructions will be like that. Here move direct comma a is, this direct is operand 1, a is operand 2. So this move instruction should be in this format only. Okay, that is move instruction. See, in always in 8051 the instructions will move from left to right. Okay, move a comma hash data is that data will move to a register. Here Rn to A is the data will moving from register to accumulator. from direct addressing to accumulator. That is the arrow mark given in this side. That is data is moving from left to right. That is the instructions. Not only for move instruction, for all instructions, the data will move from left to right only in 8051. Here, if hash is indicated before any value or an address, that is, it is going to use an immediate addressing mode. Okay, it is going to transfer the data immediately from one destination to other. That indicates hash. Whereas this ampersand symbol indicates indirect mode of addressing. It is indirectly going to access. Okay, this direct is that it's a direct addressing, and this R and all comes under register addressing. Okay, and this indexed addressing is that it will always point the code. Okay, this move C will comes under indexed. What is that index is that it will always have a code pointer towards it. That is move C. Okay, see, move C should be written in a format A at A plus register. Any register we can have in that. Okay, next move X is that move X operand 1 comma operand 2. Pop is that it is a decrement operation performed, that is value from stack. From stack to it is going to give it to the other destination field, whereas push is that it is the value pushing into the stack. Okay, this push is that operation which will increment, and pop is operation which is decremental. This exchange is a register. Okay, it should be in a format A comma register. So I can move it any accumulator or a register. Okay, or I can why they haven't mentioned here A comma Rn is that because defaultly it will transfer an accumulator with a register. Here we have given not a syntax. Okay, this is an instructions, types of instructions we are using in 8051. This is a syntax. Okay, before writing an instruction, okay, I need to write a syntax of that particular mnemonic. After that only I need to write that instruction. Okay, so this is a syntax for exchange A comma register. In a description, if you see here, they have given exchange Rn, that is they are going to exchange an accumulator with Rn register. Okay, here exchange accumulator with direct byte. Here exchange accumulator with indirect RAM. Okay, this Ri indicates indirect RAM. Okay, next one is a exchange D indicates digit. If I'm going to transfer any digit, then I can use this exchange digit A register. Okay, that is, it is going to exchange accumulator with either in lower order indirect RAM or with the higher order indirect RAM. Okay, that is the instruction. If I'm going to change it, exchange digit with the indirect RAM, I can use that exchange digit accumulator with indirect RAM is at Ri. Okay, if I'm going to use it with the higher order RAM, then I need to use it exchange digit A comma at R0. Okay, this is the various types of data transfer instructions. Before writing these instructions, we need to know about what are the syntax we are following in an instruction set. Because syntax is nothing but it's like a formula. We need to write in that particular pattern only those instructions. Okay, unless without following this pattern, this instruction, if I'm writing an instruction in a general way or in my own way, this 8051 microcontroller will not accept it. So before writing an instruction, we need to follow what procedure it need to be written. Okay, that is the syntax indicates. So by keeping this as a reference, I can write any instructions. Okay, that is a syntax and data transfer instructions we are using in 8051. Next one is arithmetic instruction. See, all types of instructions will have a syntax. Okay, in particular procedure only I need to follow the instruction. Okay, I cannot write in my own way. Okay, see here, some instructions we are using it as arithmetic means normally will perform addition, subtraction, multiplication, division. That's what we are going to use in this instruction set also. See, add A comma operand is that I'm going to add two values. Okay, I'm going to add two values. That is one is stored in an accumulator, and next one is the input I'm going to give it. Okay, that is before this step I'll move an instruction. Okay, that is move a comma, some value will be given. Okay, next step is add a comma, some value. Let me explain you. If before this instruction, how we can write is that if I'm giving, okay, move, because in move instruction also we need to write operand 1 comma operand 2. Okay, that is move a comma hash 25. Okay, this is the first instruction. Next instruction I'm going to give is add a comma hash 50. Okay, if I'm giving an instruction like this, what this will do is initially move a comma hash 25 is that this 25 is the value which will be moved to this accumulator. Okay, now next instruction is what, add a comma hash 50. Already what data is stored in an accumulator, 25. So now I'm going to add this 25 and 50, because one data is given already using a move instruction, that is to be stored in accumulator. Next instruction I'm going to give is add a comma hash 50. That is that what value is stored in an accumulator, that number and also this number have to add. So now what we will get, 75. That is a add instruction. Okay. Similarly, sub instruction will also follows. Add carry. What is this add? See is that add carry a comma operand. That is, if I'm having any carry in an accumulator, add along with that carry. Next one is multiplication. That is, whenever I'm using mul and division operations, automatically this B register will comes then. Okay, because the B register needs to store a higher bytes. Okay, so automatically this will come in multiplication. While in division, this B register will store a remainder value, so automatically it will comes in. For other types of instructions, this B register will not function. Okay, next one is a decrement register. Decrement is that I'm going to decrease the value, so it is using a minus. Okay, if I'm incrementing, then it is plus. Okay, next one is what is this DAD, is the decimal adjust accumulator. If I'm getting any decimal value, if I need to round off it, I can use this decimal adjust accumulator. Okay, this is not DAD, this is DAA. Decimal adjust accumulator. Okay, not D. These are the some types of arithmetic instruction. For every instruction, I need to follow this syntax format. Okay, after that only I can use this in the instruction format. Okay, see, add a comma hash data. This instruction I have used here. Data what I have given is 50. So it's similarly in this format syntax. Okay, so by using the syntax only we can write the instruction set. Okay, add a plus data. That is the description. Okay, already one data is stored in accumulator, next one is the data. Similarly, all steps will be carried out like this. Okay, this is arithmetic instruction. Next one is a logical instruction. What is a logical instruction is that, similarly, if I want to multiply the two instructions, then I will use AND logic. What is the syntax of AND logic? Is a operand 1 comma operand 2. ANL operand 1 comma operand 2. So operand 1 is this A, operand 2 is this data. Okay, next one is OR. Not only we can use the data, we can access it from register or from direct addressing, indirect addressing, anywhere we can access it. Okay, next one is XORL, also follows the same pattern. So CLR register is the clear register. Okay, clear is that if I'm performing an AND operation. Okay, next I need to perform XOR operation. Before that, if I want to clear my accumulator, at that time I can use this clear register. Which register I need to clear? I can use here. Here I have given an example as clear A, that is clear accumulator I given. I can also use clear RN. What register N indicates 0 to 7. Okay, total 8 bits we are having, so 8-bit register 0 to 7. If I'm giving move A comma R2, then if I need to clear R2 means CLR R2. So R2 register will get cleared. Next one is complement. Complement is a logic. If I'm taking a stored value in accumulator as A, 0 0. Okay. If I want to take complement, that is A bar, then what will get? 1 1. Okay. So how we need to write is, I should not write as A bar. CPLA. CPLA means what is the meaning is that automatically it will take A bar. That is complement. Okay, that is CPLA instruction should use. Next, these are all the shifting operators. In this, these are the shifting operators. What is the shifting operators is that if I want to rotate a data, okay, if I want to rotate a data with the left or right, I can use this shifting operators. Okay, here we are having 8 bits. Okay, 1, 2, 3, 4, 5. Here we are having 8 bits. If I want to exchange a bit to this 25 I'm having here, if I want to shift it to left means where I can shift. In anywhere, which location I need to shift, I can shift it. This is rotate left. Okay, if I want to rotate right from this value, here I'm having 17. If I want to rotate to this side means I can use the rotate right instruction. Okay, if I want to shift along with carry, then I can use this RRC A or LFC A. Okay, that is left with carry. Okay, along with carry, I am going to shift an instruction. Next one is a swap A. Swap A is that it will swap the nibbles within the accumulator. Okay, here I am having one value as 10. Okay, in accumulator, I am having a value as 25. Okay. If I want to swap it, okay, this 25 with 10 means, then I can use swap A. Okay, that is, if in accumulator I'm having a 25 means, if this is swap A I have given is that it will swap along with this value. That is, the values get replaced. Okay, that is called as a swap instruction. These are the some logical instructions we are using in 8051. Next one is a Boolean or bit instructions. Bit manipulation instruction is that what is this rel or RLEADDR is that it is a relative address. Okay, accurately not, it is will correspond it to the relative addresses or bit addresses. Okay, see, CLRC indicates a carry bit as well as a bit. Okay, see here we will use both as well as carry as well as a bit. If I'm replace this with a carry bit also, I can use these instructions. If I want to directly access it with bit also, I can use these bits. Okay, one simple example I'll give us. If I'm going to set a bit in a port pin, okay, I'm going to set a bit in a port pin, that is set B P 2.5. Okay, this is the syntax I have written. What the syntax indicates is that I'm going to set a port pin 2.5. What is that? Port, this is the port address. Okay, this 2 is a port address. I'm going to set a bit 5th pin. Okay, this is a bit. Okay, port pin. If I'm going to set a particular pin or a particular bit, at the time I can use this set bit instructions or any whatever instructions I can use that. Okay, if I'm going to use bit as JC, relative address is that I'm going to jump to my address if carry is set. Okay, for all those things and all, you'll follow the same addresses. JC relative address, JNC is the jump if no carry is not, if carry is not set. Okay, if carry is set to particular address, I need to jump C. If JC, okay, I'm giving it 8023. That is, if any carry is set, okay, then jump to this address. Okay, and again I'm giving one address, JNC 8030. If no carry is set, then jump to this address. These are all the some conditional like instructions. Okay. If direct bit is not set, then I can mention any address here. That is the bit address or relative address. Okay. If no carry is not, if carry is not set or if any bit is not set, then you can move to this instruction. Okay. These are all the some instruction types. Okay. While we are discussing about programs, we'll clear what are these instructions. Next one is program branching instructions. What is this branching instruction is that branching is that if I'm calling a routine subroutine, I can use this type of instructions. Mainly for call instructions, we'll use this branching instructions. Okay, here there are two types of call we are having: conditional calls and unconditional calls. Okay, conditional calls as well as unconditional calls we are having. What is this conditional call and unconditional call is that if I'm using a conditional instructions, then that comes under conditional call. If I'm using unconditional instructions, then it will comes under unconditional call. Here I'm having a call as a code address. Here the code address is 1116. Okay, a call is that absolute call. Okay, I'm going to call in a particular place. Okay, that is program counter plus 2 to stack pointer. Okay, here the address 11 is the program counter. Indirectly, they'll be giving it. Okay, that is a call. Absolutely, I'm going to call an instruction. What is this L call? Is a long subroutine call. Okay, if I'm having a program in a first stage, okay, that is initial stage. If I'm having a program, okay, if I want to just one instruction, I'm giving 8005. Okay, 8005. Move a comma hash 0 1. Okay, inside we are having some instructions. Next I'm going to write lcall 8030. What does this indicates? This lcall is that it is the delay routine program. Okay, that is, this is the address of a main program. Okay, and this will be the address, starting address of the delay program. Okay, here I have written an instruction as in a main program. Okay, if I want to give some delay, some example I'm giving us, let us consider an example of a stepper motor and a matrix keyboard. Okay, so while writing a matrix keyboard and all, we need to check the conditions for 4 stages, that is for 4 rows or 4 columns. We need to check the condition. So if I'm giving a first row operation, okay, first row operation starts from this 8005. Okay, and next I need to give some delay to that program. Okay, so that only it will compare it with next row operation or column operation. So at that time I can use this L call 8030, that is to execute the matrix keyboard for each row we need a delay program. Okay, so at that time we can use this long call subroutine. Okay, I need to execute for a 7 segment LED and all. If I want to execute one set of condition itself, I need a help of a delay program, because it needs to give some delay, okay, to the execute the input I have given. Okay, so for that purpose and all, I'm using this L call. Mainly for delay programs, you'll use this L call instructions. That is, A jump is also similar to absolute jump. L jump will use in delay side. Okay, next CJNE is that comparing the values. Okay, if I'm comparing one or two datas, okay, if the comparison is not equal, then I can go to my destination address, what I have given there. Okay, these are all comes along with the address. See, for CJNE, if I'm writing a value, CJNE, okay, CJNE, A comma B, and one address I can give it. Okay, here I am giving address as 8009. What is that? Is that it will compare these two operands. Okay, if they are not equal, then it will move to this address. Okay, if they are equal, then it will proceed with the next instruction. That is a CJNE. While discussing about programs, you will understand clearly about that. What is that return? Is that return from subroutine or return from interrupt? I'm going to again return to interrupt, then I can use this. Next, I'm going to use SJMP. SJMP is nothing but it is a short jump instructions. Okay, short jump means in the same line if I'm using an instruction, or in the same line if I'm going to finish it. Okay, if I'm going to finish my program, then I can use this SJMP halt. That is a short jump. So just it is going to move up upon only one instruction. That is a short jump. Okay, these are all the some program branching instructions. Okay, if I'm going to if I'm not going to operate any operations there, then I can use this no operation instructions also. Okay, these are all the various types of instruction set we are having in a 8051. Okay, in our next sessions we'll discuss about some of the programs using this mnemonic codings. Then we will clear about this program instruction set. Okay, while discussing about the programs, please have a look of the syntax and check the instructions. You will understand it clearly. Okay, we'll continue in the next session by using addressing modes and some mnemonics. Thank you.